So we'll go to the next topic, that is operation on processes. So under this we are going to see about process creation and process termination. So we'll begin with process creation. A process may create several new processes during the course of its execution. So creating process, so a process which has created a new process called as a parent, and a process which has been created, or the sub process, you can call it as a child or the children process. When a process creates a new process, two possibilities can exist in terms of execution as well as two possibilities in terms of address space. So in terms of execution, what are the two possibilities? Parent continue to execute concurrently with the children. So both the parent as well as the child, both will be executing concurrently. The next possibility is parent will wait until some or all of its children has been terminated. So in terms of execution, what are the two possibilities? Both the parent as well as the child will be executing concurrently. The next one is parent will wait until some or all of its child has been terminated. Terminated in the sense it has completed its task. And what the process has to do, it has completed, that is terminated, it's no more required. There is also two possibilities in terms of address space. In terms of address space, the child process can be a duplicate of the parent process. That is one possibility. Or you can say there is another copy of the child. So child is nothing but a copy of the parent process. So whatever is there in the parent process, same thing will be there in the child process also. The next possibility is there is an address space. Next possibility is child process has a program loaded into it. So this is in terms of address space. Now they have given you a diagram in your textbook, that is the tree of processes in a typical Solaris system. So Solaris system, in this the Unix operating system has been used. So the you can see here we are having different processes. So it is shown in terms of a tree structure. So to begin with, you have the scheduler process wherein the PID is equal to 0. So this process is usually used for paging. It is a part of the kernel. It is having a PID as PID is nothing but the process ID. Now, how you have a USN number to uniquely identify each of the student, similarly, processes are also having the PID. PID is a unique integer value to identify a process. So you can see here the scheduler process is having PID equal to 0. So this acts as a parent of all the processes, that is init, pageout, as well as FS flush, that is file system flush. So scheduler is acting as a parent wherein PID equal to 0. Next you have the init process wherein PID equal to 1. Then you have pageout. Then you have FS flush. So init is acting as a parent for all the user processes. So you can see here from init you have inetd, dt login, then you have telnet domain, x sessions. So all these are the user processes. So init is acting as a parent for all the user processes. Then you have the pageout, who is having a PID equal to 0. So pageout is a process usually used for memory management. Then you have FS flush, that is used for the file management. So that's a process which is used for file management. Next we'll come back to init. So init, or the initial process, which is acting as a parent for all the user processes. So init is having two children, that is inetd as well as dt login. So inetd is a process that is used to perform the network related function, who is having a PID as 140. Then this inetd is creating a child process, that is a telnet process with the PID 77776. Then this telnet domain is going to create a process, that is the shell. So shell is nothing but it is used for the user to interact with the system. So the shell which is used here is C shell. So in this C shell, or this particular process, again it starts two user process, that is Netscape as well as Emacs. Netscape, as we all know, that is a browser which the user has opened, will assume here, as well as Emacs. Emacs is nothing but the editor. Now how you have the text editor, similarly you have the Emacs editor. So through the C shell, that is through this interface the user has been using Netscape as well as Emacs. So this is the process which comes under init. Next one you have the next child process from init is dt login. So dt login, it serves as a X window session for user, or in other way you can say this is a process which is going to create the login screen for the user. So with the PID is 251, again this dt login is going to create a child process, that is it is created a process for the session for the user. Then this session in turn has created the child as a standard shell, that is here again the shell process as we are using is a C shell, wherein again through this shell the user can give the command that is a sub, you can call it as a sub process or the child process. The way the user is using the command ls. So ls is used to list all the files in the directory, as well as cat command that is used that is concatenate, or to read the contents also you can use a cat command in Unix. So please, in case if this is asked, you to draw the diagram and you to explain each one of this. So I've not put in the notes, so please listen this video and write each one of the points in your own words. Okay, next we'll come back. Process creation, you have one more diagram here. So we know fork is a system call which can create a new process. Okay, each process is identified by the process identifier that we already said with a unique integer. A process can be created by the fork system call. So you can see here the fork system call has created a new process, that's a child process. Okay, and it is executing. So you can see here you have the parent. So what did we say here in here? The parent can wait until the child has completed or terminated. Okay, so here what is happening, fork has created a new child process and the parent is waiting. So you can see here fork has created a new child process and it is executing, and the parent process is in the waiting state, it is waiting for the child to complete. So when the child has exited, then the parent is going to resume his operation. So that's what is told in this diagram. Here you have a sample C code about forking. So you can see here we have PID. PID is nothing but the unique identifier for a process. So you can see here fork system call is going to create a new process, and for that process a PID is generated and that is stored in this PID. If the PID is less than 0, then what is happening, the fork has failed, no child process has created. Else if the PID is equal to 0, then what is the meaning of this, a child process has been created, then it is going to execute this particular path. That is one thing. Else, what is a else, what's the last option, the parent is waiting for the child to complete. You are seeing here the wait. So parent will wait for the child to complete. Once it is completed, then it is going to exit. Other than this, you have some header file that is sys type that is used for PID. Okay, next we'll come to process termination. So we know process, once it has completed its execution, finally it has to terminate. Okay, so process terminates when it's finished its execution and asks the operating system to delete it by using the exit system call. So when the process completed its task, then it can offer the exit system call wherein it is trying to terminate. At that point, process may return output to its parent via the wait system call. So when the child process is been terminating, it can return the result to the parent process. Process can cause a termination of another process via the appropriate. So a process can also terminate another process. So here in the first point you're saying the child can terminate, that time the child is going to return the result to the parent, and the other case we are saying here a process can also terminate other processes via the system calls. Parent may terminate the execution of one of its children for a variety of reason. So we have the parent process, you have the child process. So here some reasons when a parent can terminate a child. What are the reasons? The first case is child has exceeded its usage of some resource that has been allocated. So the child is being given some resource. It has to use only this resource. But if the child has crossed that border, okay. So just take an example. Suppose we are given pocket money of some per day some 200 rupees. If we have spent all those and after that still we are taking something more, that is something you have exceeded the limit. So in such cases it can happen that parent might stop giving you any pocket money. So just an example here, what we'll say is, if the child has exceeded, so suppose the child had to use only two resources, but if it is trying to use three resources, then in such case what will the parent do? Parent will tell, no need of executing, you just terminate. Task, that is one case. Next case is task assigned to the child is no longer required. So the child process had to do some job, that job is completed. In such case, parent can terminate the child. The third possibility is parent itself is executing and the operating system does not allow the child to continue if its parents terminate. So what's the third case? Parent itself is exiting or terminating. In such case, child also should be terminated. So you cannot have an orphan child. On such system, if a process terminates, then all its children must also terminate. This is called as cascading termination. So what's the meaning of cascading termination? So suppose a parent is having three children. So if the parent terminates, all the three children also should be terminated. So this process is called as cascading termination. I hope you have understood. Thank you.